bit technological, because licenses only cover very certain issues, and as there are different approaches to VM, would this cover, do you think, most of them, or are we going to see something that's going to happen differently now because of it, in your opinion? Or what are the engineering paths that can be taken?
Can you translate again? Thank you.
Basically, what kind of horrible hacks are we going to have to do to get around the legal barriers to virtualization?
Thank you! Dan fucking Kaminsky, everybody!
I just translate it.
That is a good one. Do they say CPUs? Do they say machines? Maybe you can have something like CPU affinity. If they say, for example, CPUs, you can only have it on, you cannot have more instances of this thing on one CPU. Then if you have a multi-CPU thing, you could bind one virtual machine to every CPU.
Okay, that's awesome.
Now Microsoft is getting ideas.
Can you detail how Xen compares to VMware?
Of what?
How Xen compares to VMware?
Xen and VMware are quite different solutions. VMware is always running on top of one operating system. Well, the workstation version is always running on top of one operating system, and also only the server versions have their own hypervisor and all the operating systems running on top of them. Xen has only the second approach. Xen is always the underlying thing, with one of the operating systems being the I'm not sure about the nomenclature, being the one operating system which can drive the actual hardware, and the other ones that are completely virtualized. So that's a very different approach of all that. Also, VMware has mostly been done for virtualizing mostly Windows, and any other operating system that you either don't have the source code for, so you cannot modify the operating system, or you don't want to modify the operating system because you just want to have your Red Hat disk and use that. And Xen is mostly, before VT, Xen has been done for pre-virtualized operating systems or para-virtualized operating systems. So the operating system that you run as a guest is aware that it is running inside of a virtual machine. So all these instructions that make problems won't trap, but they explicitly trap by calling the hypervisor. For example, there won't be something like a CR3 reload by move EAX, CR3, but it will be a call to the hypervisor saying, I would like to load another address space, which is easier for the hypervisor and which is also better for performance. So this is the whole idea behind Xen. So with VT and SVN, Xen can also do Windows virtualization or non-para-virtualized virtualization, but still the whole concept is more that of the VMware server version and not the workstation version. Yeah, Xen is cool, I agree. Yeah, I like para-virtualization because the whole. Okay, now comes one political thing. I think that the whole. This whole VT and SVN thing is just one big hack around the fact that Windows is closed source. Because if you have open source operating systems and all the operating systems that you would want to run inside of a virtual machine were open source, then there would be no need for something like that, because you could just modify the operating systems so that they are aware that they are virtualized. They're a lot faster, the hypervisor gets easier, and you can do a lot of nice hacks so that the host and the guest can communicate. It's only with closed source operating systems that all this does not work, and you need some workaround like VT or SVN.
Like at these places in public where I say, no.
Just one quick comment.
Windows is open source in a way that some people get the source of Windows, but they are not allowed to recompile it in a way that it can be paravirtualized.
Well, some people can read it.
They can read it, but they are not allowed to change it. I think there was a paravirtualized Windows someplace, but yeah.
Just
So
one comment
Is this the
on-
sign that I should shut up?
No.
Nothing.
Just one comment on Xen and SVM versus VT. I spoke a lot to a Sun here. Oh.
Yeah.
Sorry. I spoke a lot to a Sun kernel engineer who works on virtualization, and what he claimed was that Pacifica helps them a lot to improve the performance with paravirtualization. So whereas VT is for them basically useless, running Solaris on Xen with a slightly modified Xen that makes use of all of the Pacifica functionality gives them a lot of performance advantage.
Yep.
So it doesn't really help in the virtual machine monitor case, but in the hypervisor case, Pacifica helps a lot.
Yeah. There's one thing. Well, VT doesn't really help. VT is really that workaround again around closed source. But SVM has one nice extra feature, and VT is going to have this feature as well in the future. I think the Intel's roadmap says, which is nested page tables. So there was one slide here that I don't know how to find again, but I think you can remember that slide about the two ways to, or the two steps to get from your virtual address inside a process to get to the virtual address of your operating system to get to the physical address of the machine. This has to be done manually by the hypervisor every time a page table entry is done. With a nested page table, this is a feature that only SVM has so far. You have two complete MMUs, which are an S or which are one behind the other. So you can actually have your real page tables. You don't have to translate them. You don't get all the nasty TLB problems with that. And the hardware can actually do the whole thing, which will lead to a lot better performance. But VT will eventually have that as well. And this is one thing that not only real virtualization, but also paravirtualization can make use of.